Good morning, everybody. I'm Alan Pangbourne. I'm the CEO of Chesapeake Gold. We recently took over management at the beginning of January this year of Chesapeake Gold, and we've got an exciting new way to approach the project with a significantly lower capital and a completely new process. So I'll just walk you through what our plans are and what we've done in this last 8 months or so. The typical cautionary notes, so we all read these before. Some highlights about the project. Firstly, it is a very, very large deposit. It's over 20 million ounces of gold and over 560 million ounces of silver. It's located in Durango in Mexico. When we took over, we identified that there was an interesting higher grade core to the deposit, and so we're really focused on that, and we're looking for a smaller starter project so as we can get it into operations and then expand up, rather than the previous plan, which was a very large, highly capital intensive project, which would have been very, very difficult for a company like Chesapeake to actually finance. When we joined Chesapeake, we actually came with a technology that allows us to heap leach sulfides, convert them into oxides, and then leach the gold and silver. It's a totally new concept into the gold industry. However, it's not new. It's been done for over 30 years in the copper industry. I worked in the copper industry with BHP. I actually built the largest sulfide heap leach in the world back in 2004. And they've been successfully producing copper predominantly in South America, probably over 1.5 million tons a year at the moment from multiple operations, where they oxidize the sulfides, recover the copper sulfate that comes out, and then make cathodes out of it with SXEW. So it's the same concept brought across to the gold industry, where we'll oxidize the pyrite. That has significant impacts on capital, operating costs, but it's also greener. If you look at the other processes to recover gold from refractories, it's either roasters, smelters, or autoclaves. Our process uses 90% less water, 90% less power, and there's no tailings dams. Those are really important when you're talking to the local communities, because they're all concerned about their water supply, and given some of the recent incidents related to tailings dams, nobody wants to be living anywhere near one. So our process eliminates many of those issues. We recently released a PEA. It's on our website now, and it's on CEDAR, and please have a look. There's also a copy of this presentation, but a much more detailed one with many more slides with more information about what we've done. But the PEA demonstrates that we have a credible route to production. It also shows that it's a financeable size project for a company like ourselves. It's certainly deliverable at only 15,000 tonne a day crushing plant, and then expandable multiple times to take advantage of that massive resource that we have. As I mentioned, we're in Durango. Previously, I was the COO at SSR. Worked in Durango. We had a project there. I've taken one project through the permitting process there, so I understand how all that works. Well funded. We have $35 million in the bank. That, we believe, is enough to take us all the way through to the end of the feasibility study, and then we'll be looking for construction financing. Large shareholders, two major shareholders outside of management are Eric Sprott with 8.4 million shares out of 67 million. And then Peter Palmetto owns about 7.3. Management has over 22% interest in the company as well. So that shows a significant commitment to this project, and also a significant level of skin in the game when it comes to moving the project forward. As I mentioned, it's a large ore body. I won't repeat that, but what we've really focused on is that 166 million tonnes of 0.76 gold, 15 grams silver. That's about 1 gram equivalent. If this was an oxide ore body, it would have been mined long ago as a heap leach. We've got this process that allows us to turn it into an oxide ore body faster than nature will. And that obviously leads to much lower capital costs, processing costs, and therefore superior economics. When I first joined the company, one of the first things I said to everybody was, we've got to go and get some fresh samples so we know what we're testing, we know where it came from, we know what it represents. We also focused the holes to make sure that we got the three major rock types, which is sedimentary, the intrusive, and an intrusive breccia between the sedimentary and the intrusive. Interestingly, after we drilled the holes, they were core PQ size, so 3.5-inch core, so big enough to do heap leach test work on. When we assayed them and compared them back to the block model, they were 18% higher grade. That is certainly a nice surprise, and certainly better than the opposite direction. So now, given that, I work with the geologist who worked with me at SSR, and we've decided that we're going to do another 15 holes, and we're going to run 3 more fences. We'll put 1 in front of that large hole, and then 2 behind it, basically to see if that higher grade core in the high grade core is extensive. If it is, we'll obviously use that data, upgrade the block model, and come out with a PFS in this time next year. So that drilling will start in November. Hope to have the results back by late Q1. Hopefully they're as equally surprising as these ones were. This slide just shows the outline of the PEA pit. The PEA only considers 20% of the resource as the starter project. So the red line shows the outside of that. It is completely focused on the intrusive ore. There is sedimentary ore out here that will be stockpiled for later processing, and you can see the outline of the overall resource. The other thing we found out once we got in, before we did the deal with Chesapeake, we did actually get some samples and we checked that our chemistry would work. What we didn't know once we'd done the chemistry was time to do it, because they didn't have any coarse material. Once we got inside the company and actually talked to the technical people, they said, oh yeah, we've got a couple of drums sitting in Denver. We're not quite sure how old they are. We believe they're about 6 years old, but they have been kept dry all that time. And so we set up a column in the lab that we're going to use for all of our test work, just to sort out all the bugs. Yeah, make sure that the irrigation system's okay, that it doesn't start blocking up, the air injection at the bottom works okay, and we don't flood it, and a whole bunch of other things around assays, frequency, and what we're assaying for. And then we just let it run. So this was the ore fresh, literally 2 hours after we loaded the column. I actually took that photo when we loaded it. And then as you can see over time, and that's just under 90 days, how it's changed color. That color change is iron oxide. So that's your pyrite decomposing to iron oxide at a significantly faster rate than you would normally see in nature. And so that's the first indication at this size particles that the process we're using in a column, these are 6-inch diameter, 8 foot tall, is working. That column is still running. We'll run it out for another 30, 35 days or so, pull it down, go to the second stage, which is the typical cyanide heap leach, and then see what the gold recoveries are and silver recoveries, and we'll be able to tell what the oxidation rate is. We know it's working. We know it's iron oxide because we're measuring the sulfate coming out the bottom. The other thing that came out of the PEA and the other major difference from the previous project is the layout. Everything is now much more compact. Everything is on site. Previously, there was a plant down near Kossala, there was the plant up at the mine, and all of the infrastructure that connected it. And so on this slide, what you can actually see, the obvious one is the pit. This is the sedimentary stockpile. That one and that one are waste stockpiles. This is the oxidation pad. That's large enough for an oxidation time of 180 days, 7 meters high. It is almost identical to what we were building in the copper industry. Air injection built into the bottom, 7 meters high, as I said. Copper, we were running anywhere up to 10 meters high. It'll be an on-off pad. And the reason we do it like that is it allows us to control both the physics and the chemistry of that pad. We can control permeability, oxygen levels, chemical levels, irrigation rates, and the like. And we don't get into questions about, as you stack material one on top of the other, is it working like it should? We would then take the material off. It would go into this big red large area. That's big enough for the entire 166 million tons. It's a permanent valley fill, same as every other oxide gold heap leach you've seen around the world that's done a valley fill, and then Merrill-Crowe gold and silver recovery because of the high silver levels. We've also identified an area where we would put the second pad. It's not the easiest to see, but it's approximately in that area there. That would allow us, once we've got it built up, running, and show that it's all working, that we can double the capacity and go from 15,000 to 30,000 tons very easily and very quickly. The summary of the PEA. So instead of a $3.5 billion capital, we're looking at a $360 million capital, which I think everybody will agree is much more financeable for a smaller company like ourselves. 15,000 tons a day, as I said, grades, same as earlier, about 1 gram equivalent. 31-year mine life. Many people have said, why have you let it run out so long? It's risk mitigation. The previous project was a massive project, probably right-sized for the resource, but you could never finance it, and if you got it wrong, you blew the company up. A smaller project that you can step into. It's a true and tried, tested process. We've been doing it for donkey's years. Most large projects were never, ever built to full-size day one. Yeah, we stepped into them, understood what we were doing, then expanded. Escondida, Grasberg, all of the major projects took their time and got up to the final sizes. It'll produce 112,000 ounces of gold a year on average over the first 15 years of that 31 years, and an additional 2.5 million ounces of silver over the same time period. If you take the silver as a byproduct credit, we end up with an estimated cash cost of $690 and an AISC cost of $750. So that's a pretty robust project that will allow us to keep moving forward and hopefully bring this into production in the future. That was all based on $1,600 gold, $22 silver, which was consensus from one of the banks recently. That gave us a 1.4 billion Canadian dollar NPV with a 35% return. If you go to spot prices, that goes up to 1.9 billion Canadian and a 45% return. Timeline, predominantly it's driven by Testwork. The samples actually arrived in the lab in Vancouver yesterday, finally from Mexico, from that drilling program, so we can actually get the main columns running now. If you split that time, the metallurgical test work in half, it's really two pieces. It's the three composites, work out size effects, concentration effects, time, oxidation to recovery on composites. And then the second half is all about variability. So we'll have over 20 holes that we can take individual samples down those holes, know exactly where they came from, what the mineralogy was, and test individual samples to give us the variability over that intrusive ore body. We expect to have the results from the first phase in Q2 next year. We expect to have the results from the additional drilling in Q1 next year. That will all lead into a PFS, which hopefully I'll be able to stand here next year and tell you the results from that. Once I've got the pre-feasibility study, I can start the environmental impact statement in Mexico. That's probably the longest timeline you've ever seen for a permit in Mexico. The reason is really simple. I don't like trying to control governments. I'll put the things on there that I can control. Where I can't control them, I give it room. Typically, that's taken 12 to 18 months in Mexico, so there's a bit of float there. Once I've got the variability test work finished, we'll start putting together the definitive feasibility study, and we expect that to be out in late 2023. As is typical, once I've got a feasibility study, I can go look for construction financing. And as I said earlier, we believe we've got enough money to get us all the way to that point. Once I have my money plus permits usually means I get to put my boots back on and go and build something. Take about 12 months. That schedule's about right. I built a project in Peru back in 2000 that was about the same size, and it took me 11.5 months. And, oh, it says my time's up. And then production in 2026.
Right. Final comment?
Final comment, we're cheap. We're underrated. It's an overhang from the previous project, and we expect to see that re-rate as people understand the project. There you go.
Thanks so much, Alan. We look forward to an update in the coming months.
Thank
you.